Okay, guys, so this is the extended version. So, like I've told you over and over again in class, I'm not expecting you to watch the whole thing. Look for the ones, fast forward to the ones that you didn't get right, and take notes on how to do those right. And then again, you looked at it, you didn't know how to do it. It's okay to not know how to do it. That's why we're talking about right now. I'm trying to be really, really clear. We're pretty sure you've seen this for 3 years, but that doesn't mean you learned it for 3 years. But we're trying to remind you of what it was. And, if you have, this is where I expect to see a lot of questions on this lesson, because 4 out of 3 people struggle with fractions. And so, we're expecting a lot of people to come and get help. And, nobody laughs at it because nobody understands the fractions. But eventually, once you understand, you'll hear that. And, well, for a little while, then it just become old hat. So I told you in the first video, in the original video, I told you how I did 2436. Now, by now you've started doing some prime factoring. So I'm going to just show you real quick how I would do it with prime factoring. So 24 factored completely is 2 times 2 times 2 times 3. And 36 factored completely is 2 times 2 times 3 times 3. Now all I have to do is look and say, well, what do they have in common? And on the top and the bottom, 2 divided by 2 is 1. So that makes a 1. And then there's another 2 divided by 2, and there's a 3 over 3. So those all make 1s. So that all that's left is 2 over 3. So that becomes my answer, 2 over 3. Okay. And again, if you got these right, you could watch it. It wouldn't hurt to watch it. So the 2 ways to do number 2 would be to say, well, if I have 20 over 45, the first way you probably learned in elementary school was to look at it and say, well, what goes into both of them? So if I look, I know that 20 is 4 times 5, and I know that 45 is 9 times 5. So I can see they have a 5 in common. So 5 divided by 5 is 1. Okay, so that means what I've got left is 4/9. Now, if I were to do it with prime factorization, you're going to make a hundreds chart in the next week or so. So this will become a useful tool for when we get into fractions. And so if you had your hundreds chart, you would just simply look and say, well, 20 is 2 times 2 times 5, and 45 is 3 times 3 times 5. You could see that the 5s are the only things that reduce. That's the advantage of a hundreds chart or prime factorization, is you can see that the only thing they have in common is that 5. And then you just simplify what's left. If 5 divided by 5 is a 1, then on top you're left with 4, because 2 times 2 is 4 ninths. There you go. Okay. All right, so let's look at this next one. So now when you are adding and subtracting fractions, okay, you have to make sure they have the same denominator, which these do. And then all you do is say, well, if I have 5/6 and I'm subtracting 1/6, then really, and some students will tell me this is the first time they've ever seen it like this. But what I would be doing with it is say, well, it's all over 6 because they both have a 6 as a common denominator, right? So you got the 6 as a common denominator. Really, all you're doing is saying, then what is 5 minus 1? 5 minus 1 is 4, so you got 4/6. Then you have to simplify that, because 4 is 2 times 2, and 6 is 2 times 3. So the 2's reduce. And what we're left with is, because 2 divided by 2 is 1, right? Not 0. And so it equals 2/3. This one's a little harder because it becomes what I call a usable fraction. And I know that some teachers in elementary school are starting to call this a usable fraction, because it's the way you would set it up. You've also learned it as an improper fraction, but the improper fraction is the one you will use in science, okay? But again, if I have the same denominator already, then all I'm really doing is putting the 12 on the bottom and saying, if I have 5 twelfths plus 17 twelfths, how many twelfths do I have altogether? And 5 plus 17 is 22. So that means I have 22 twelfths. And at this point, I can reduce this because 22 is 2 times 11, and 12 is 2 times 2 times 3. So if I have those, if I look at that, then I'm going to reduce the 2's, which leaves me with 11 6, because 2 times 3 is 6. So I could have 11 6, and that is a correct answer. That's an acceptable answer. But what you're going to need, what you're supposed to know how to do, is how to go from 11 6 to 1 and 5 6, and how to go to from 1 and 5 6 over to 11 6. Okay, because again, like I said, the 11 6 is the usable fraction. It's what you're going to use most of the time in science. Okay, even your answer in science can come out to be a usable fraction, or what you might have learned as improper fraction. Okay, so if you have 11 6, if you're confused on how to go from that, from 11 6 to 1 and 5 6, then one thing you might do, draw this out. Again, you might need some extra room for this somewhere, but this would be where you draw this in your learning journal. If you look, if you had a hole, and that hole had 6 equal sized pieces, okay, so if you drew that out, and if you filled in, that means this is, and this really should be review, but if this is 6 6 or 1, right, it's also called 1, but it's also 6 6, then 11 6 means we fill in 11 of these, so we fill in 1 2 3 4 5 6 7 8 9 10 11. That's what 11 6 represents, where it takes 6 to make a whole. That's what the denominator tells us, is how many it takes to make a whole. So if you've never heard that before, you're going to want to write that down somewhere. The denominator tells you how many it takes to make a whole, how many pieces, and the numerator tells you how many pieces you have. Okay, so when we go from an improper fraction or a usable fraction, that means we're saying how many pieces altogether do we have, and how many does it take to make a whole. When we go to a mixed number, what we're saying is, well, if that's true, then how many whole numbers do we have, and how many parts do we still have? Okay, that's why we call that a mixed number. It has whole numbers and fractions, or parts. Okay. All right, so again, if you're confused on these things, then look it over, review it, write it in your learning journal. All right, that's a good place to write the stuff that you're learning, that you've never done before, or that you're figuring it out. Put that in your learning journal. And then, or just write more in here. You have some space down below here on some of this. You might write it over there, but okay. So again, if you're learning something, that's good. Remember, you expected mistakes. You got to respect yourself and your brain, that it's so plastic that you could learn new things, and you have to learn new patterns. I'm going to teach you a way that's foundational, and you may never have seen it before, so I'm going to ask you to trust me. If you haven't drawn these pictures before, start drawing these pictures. You'll notice I draw a lot of pictures when I explain things. That's because the visual helps you understand the why. So I'm hoping you're going to figure that out. Okay, so now the difference between 3 and 4 and 5 and 6 is that they have 3 and 4 have the same denominator, 5 and 6 don't. So you've got to come up with a common denominator. Now, I don't know which way you learned. You probably learned how to list all the possible multiples and then circle the ones they had in common. You're going to use what's called the least common multiple. I'm going to teach you how to use the prime factorizations to do it when you have a hundreds chart. Okay, but today we're just going to say, well, 8 and 11 are relatively prime. They have nothing in common. So that's a word you might want to write down, maybe search and understand, is relatively prime. Okay, and so that means they have no factors in common. And so that means I'm going to have to just, my least common multiple between 8 and 11 is going to be 8 times 11. Okay, now I'm not going to tell you couldn't always do that, but I am going to tell you that if you look at number 6, and if you went 8 times 10 is 80, you're probably going to have to reduce that fraction. Now, that's okay. If that's the way you can get it done, then that's the way you can get it done. But I'm going to show you another way that makes it a little easier if you'll do what I ask you to do. Again, I'm going to show you how to ride that bike, right? And you're going to have to take some time to practice riding that bike. So you got to be willing to try what I'm going to show you, because I promise you when you get done, it's going to make your brain much more plastic. You're going to learn some things you've never thought of before, and you're going to be pretty strong with this. And what I'm going to teach you is going to help you in algebraic fractions in 9th and 10th grade. So anyway, let's go back to this, back to what you have learned. Okay, so that means 88 is the common factor, so I'm going to multiply this by 8 over 8, because 8 divided by 8 is 1. 1 times any number is that number. We're just changing the way it looks. And then you're going to multiply this side times the first one by 11 over 11. Again, because it's 1, and what we wind up with is 11 times 5 is 55, so we're going to have 55 88ths minus, and 8 times 5 is 40, so we're going to have 40 88ths. Now notice we have the same denominator, so now that we have the same denominator, we just use the same principles we were talking about here. Okay, so that means what we're going to do is we're going to put it all over 88, and we're going to say we have 55 minus 40. 55 minus 40 is 15. So it's going to be 15 88ths. The thing is 15 is only 3 times 5, and 3 doesn't go into 88, and 5 doesn't go into 88. And so that's as simple as it gets, is 1588. That's the answer. Okay. Now, when I look at 8 and 10, I know that the least common multiple between those two is 40, because 8 times 5 is 40, and 4 times 10 is 40. Now, I can show you another way. If you don't know how I got that, then bring it up in class and I'll show you. But what that means is I'm going to multiply 3/8 times, because I want them to both have 40ths for a denominator, because that's the least common multiple, right? So I have to multiply the 8 times 5, which means to keep it the same number, represent the same amount, I'm going to multiply the 3 times 5, which is going to give me 15 40ths. And then I'm going to have to multiply the 10 times 4 to get 40, which means I have to multiply the 7 times 4, which means I'm going to have 28 40ths. Okay. Well, so I have that they're both 40, that I'm 40th, so I'm really just putting a 40 on the bottom, and now I got to add 15 plus 28. And 15 plus 28 is 43. So that's 43 40ths. 43 is a prime number, so it won't reduce, and that's a usable fraction. It's improper, but that means it's usable, right? But that means I have 40 to make a whole. I have 43 pieces. That means I have one whole and 3 40ths left over. Now, drawing that whole would be a lot, right? But there we go. Okay. Okay, so again, if you know now, because for some of you it's going to be Oh yeah, that's how I do it. And so I just want you to write that down in your notes here, and we'll design a way that you can use your notes and your learning journal. So we'll have pages for your notes and pages for your learning journal. And then I'm going to suggest that you write down on the right-hand side what page that's going to be in your learning journal. I mean, I'm going to make a suggestion of those pages, but you can do what you want. It's your learning journal. If you only need one page to add to it, then add it to it. Okay? All right. So then the next thing we're doing is just the prime factorizations. So again, 51, you're just going to look at 51, and I'm going to give you a multiplication table so that you can start using these. But if you look at 51, when you go down, you just look in the multiplication table for 51. And you'll see that it's in the 3 column under 17, so it's just 3 times 17. Now remember, I told you that when you do the tree, you should be able to multiply across and still get the number you started with up here, right? So that's done. I'm done with that. Okay. And then 16, well, again, if you would have taken 16 and broken it up into two numbers that you think of that can multiply together to give you 16, and I would have thought of 4 times 4. Now, 4 times 4 is still 16. Then I would have looked and said, well, 4 breaks down to 2 times 2. And this 4 is going to be 2 times 2 also. And 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2, this is 16. So, and 2 is prime. So I'm done. So 16 is 2 times 2 times 2 times 2, which is 2 to the 4th. Because they're the base, remember this is the base, right? So this number is always our base. It's what we are repeating, right? And this number here is our exponent. How many factors, how many times are we repeating it? So we repeated this once, 1, 2, 3, 4 times. And the repeated operation is multiplication. Okay, well, that's a pretty detailed description of how to do these things. So again, you don't have to watch this whole video, but what you do want to do is fast forward to the parts you don't get and see if you can understand them and if you learn how to do them. Okay, I'm going to show you a different method on how to do prime factorization, but by now you've seen a few, and we're going to have a worksheet that we're going to start working on these so we can have those ready so we can start talking about prime factorization is. And then once you're done with that prime factorization, understanding the two methods that I've taught you, or that I will have taught you, then you're going to create a reference sheet for you to help you with your fractions. Okay, and it's going to make your fractions a lot easier, unless you already have fractions aced, and then, well, it's going to help you with some things, but for those of you that struggle with fractions, which 4 out of 3 people do, then it's going to be a big tool. It helps a lot of students. And I'll let you use that reference sheet on the test because you can't use a calculator, so you'll be able to use a multiplication table and that reference sheet, that hundreds chart. Those are the two things you get to bring on a test. Okay? All right. Hey, good luck. Write down your questions. Come to class with questions. If you watched the first video and you did it and you did those problems, you circled the ones you got right and you came back and you focused on the ones you got wrong and you came in and watched this extended video, then you have earned the right to ask questions in class. Okay? You should expect me to answer your questions. You should expect me to work until you do understand it. And I guarantee you that if you have a question and you put all this work into it, other people have the same question. Okay? There is no stupid question. Okay? There is no stupid. Okay, there is. If you ask me why I have hair in my nose, well, I think that wouldn't even be stupid. That would be that there's an answer for that reason. Okay? All right. Okay, so hey, keep it up. I'm proud of you. If you've gotten this far and you've watched this video and you're still listening to me right now, you're committed. Good job. All right. Okay, see you in class.